So first of all, let's look at the specific heat capacity formula. And as I mentioned in a previous video, and I covered this for chemistry, it's usually written as either Q equals mc delta T or E equals mc delta T. I can see that sometimes it can be confusing when you have different symbols for the same formula. And sometimes I even see the temperature, which is T, being represented as theta. The important thing to remember is the formulas are exactly the same. It's just the letters that are changing. Okay, so I'm going to stick with this one, which is E equals mc delta T, where E is the energy of the reaction in joules. M is the mass of the substance being heated. Okay, so this could be water, as it is in a lot of the chemistry examples, but in physics it could be water, it could be a metal, it could be an oil. C is the specific heat capacity of the substance, which is either you have to work that out or it's supplied to you if you've got to work out something else. And then delta T is that's your change in temperature, and that is expressed in both units. Sometimes you see it in degrees C or in Kelvin. It doesn't really matter as long as you stick with one unit. And then the mass of the substance being heated up, again, you're going to see two really common units. It's either going to be in grams or kilograms. So watch out for the units. Pay attention to the units because they will affect the heat capacity units, whether it's quoted per gram of substance being heated up or per kilogram. Right, so with that said, let's take a look at this example. So a can chiller is used to make a canned drink cooler. So basically you put a soft drink, by the looks of it, into a cooler and it cools it down. So the heat is being absorbed from the can into the machine. The initial temperature of the liquid is 25. The can chiller decreased the temperature to 20. The amount of energy transferred from the liquid was 6930. The mass of the liquid in the can was 0.33 kilograms. Calculate the specific heat capacity of the liquid, and you will notice that we have to define the unit. So as the masses are given in kilograms here, I will be quoting the heat capacity unit in terms of kilograms. Also, you will notice the energy amount supplied is in joules. Heat capacity units, let's go through this. You can either quote it as joules per gram per degree C, or kilojoules per kg degree C, or we could just leave it in joules per kilogram per degree C. It really is up to you. So I'm going to use this bottom unit. And just a quick recap, the specific heat capacity is the energy required to raise, let's use kilograms, 1 kilogram of a substance by 1 degree C. Energy required to raise 1 kilogram of a substance by 1 degree C. So let's go and work it out. So E equals mc delta T. Rearranging the equation gives me, so the energy is 6930. The mass of the liquid where the energy change is taking place, so the liquid's either being heated up or in this case being cooled down, is 0.33 and then times delta T. So the temperature starts at 25 and then is cooled to 20. So delta T would be T2 minus T1, which would be, yes, that is -5, not +5. So I'm going to put in -5 here. Gives me an answer of exactly -42000. Now I need to say at this point, the heat capacity is always quoted as a positive number. So why is this come out as negative? Well, the reason why is often this formula is sometimes quoted in data sheets with a minus sign already there. So minus mc delta T. The reason why that is because if a reaction is exothermic, the temperature will increase. However, the energy change for that reaction must be negative because energy is given out to the surroundings. And so that's what the minus sign takes care of, because you'll have a positive number times a positive heat capacity times a change in temperature, which, say it started at 20 and it went to 50, that would be positive 30. So it ensures that for exothermic reactions, the energy change, also known as the enthalpy change, is always negative. Whereas for endothermic reactions, the temperature of the system is going to decrease. So it starts higher, energy is absorbed from the surroundings, and it drops. With that minus sign there, so have a minus times a minus would equal a plus for an endothermic reaction, which is what this is. So that's the sort of technicality you need to know. However, just remember, for simplicity, the heat capacities are always quoted as positive numbers because it's the energy required to raise 1 gram or 1 kilogram of a substance by 1 degree C. So obviously you have to put energy in, so that's an endothermic process, so that must be quoted as a positive number. Finally is the unit, so it's joules per kilogram per degree C. And if you look at that number, that's reassuring because usually for reactions involving water, so heating up water, which comes up a lot in chemistry, you're usually given the value of C equals 4.2 or 4.18. So if you had this in a physics paper, that would be good because you know you've had the question right. Okay, so that's the first part. The second part of this question or this topic covered in the next video, and that involves finding the heat capacity of a metal. So please go and check that out now.